Today I'm going to present you the slide about GIS data types and databases in ArcGIS. So let's get started. We have a slide called Raster Data. So it is a grid-based spatial representation of data types, what we see in real life images, what we call, but it is the most accurate name scientifically. We can call it Raster Data. So let's see the description. I can see the raster data represent geographic phenomena as a matrix of cells, like as a pixels. It is represent data as a pixels, like we saw in images. Each cell holds a single value, and the spatial resolution determines the cell size on the ground. Just like we have learned about it in our back in the days, we have spatial resolution. Like this, it is a satellite thing, to be honest. So it is best suited for continuous phenomena such as elevation, temperature, and satellite imagery. So in the right hand of me, I have a raster image. It is a landslide suspected map of Chittagong hill tracks. We can easily visualize it. It is the most, what we can see, satellite imagery kind of representation of a raster data type rather than a direct image. So the structure of raster data type is obviously grid of rows and columns. Each cell represents single value. The resolution is cell size. We usually define with meter, and origin at top of left corner. So what does this mean? So it starts from my back in the hand, like it starts from here to there. It is the most comprehensive way to make a raster data set. So common format is actually most commonly used format is GeoTIFF. It is the most highest resolution of raster data we can use in ArcGIS, and we have ERDS imagine, like short from image, and JPEG, ASCII grid, ESRI grid. And let's move to how we define raster data set in ArcGIS Pro. So we have some key functions here that we can use to define raster data set. So there is multi types of raster data set we usually see. The basic one is so-called single band. That means one value will be defined in one cell. It's like a dam data set, which is elevation and slope. And we have multi-band data set, like RGB imagery, like 3 bands in a raster. This is called multi-band. We have mosaic data set, collection of multiple raster data set. Like if I want to make a landscape cover of Khulna, I have to mosaic 5 landscape imagery to get the exact cover of Khulna from landscape imagery. We have raster catalog, a catalog that contains multiple raster data set. We have an image service that server published raster as via URL. And to be honest, the key ArcGIS raster tools are the most important. So we have spatial analyze. These are the most of the use tool we're gonna use in later of our video. And we have 3D analyst tool, we have image analyst tool, we have raster functions that we use to define our raster data set. Okay, so now I have vector data. So it is the opposite of raster data. Raster data set is grid based. It is actually, there are 3 types of vector data set we usually found. One is point based, one is line based, one is polygon based. So first of all, I am gonna give you an overview of what a point database is or a line polygon database is. So vector data represents geographic features using discrete geometric primitives like points, lines, and polygons, each associated with attribute information. So if we open ArcGIS, we can actually visualize and we can actually see the table which forms the vector data set. It is ideal for discrete bounded features such as roads, rivers, parcel boundaries, and city location. So in my here you can see it is a vector database. These are the routes, and routes are visualized like this. So this is the most common used of vector data set. So we can actually see the lines. It is a line format of vector data set, and this is the map of how the Dhaka looks like when it is inundated in water. So moving into next slide of our you will see how does our vector dataset looks in ArcGIS Pro. So we have multiple vector formats. Shapefile is the most commonly used format. It is the made from ESRI, and it is required for multiple files to form, and it is actually stored in a folder geodatabase we will learn about later. It has feature class, native geodatabase format, no limit, no 2GB limit, topology support. It is the most modern version of Shapefile, we can say. And we have KML, KMZ, GeoJSON, geodatabase, feature dataset, and how our attribute table actually looks like. So if I want to show you here, so this is our attribute table looks like. These are the FID, we have the shape type, name of the column, name of the rows. We can define rows and columns. We can define different kinds of rows just like we do in Excel, I guess. So what are the most commonly used types when we use vector dataset? We actually perform geoprocessing like leap, dissolve, buffer, union, intersect, editing tools. We create features, reshape it, topology editing, snapping, etc. And we have also selection and query, select by attribute, select by location, definition, query, statistics. So these are the most commonly used type we usually do with a vector dataset. And now let's me just compare with that raster dataset versus vector dataset. So in my left side I have got a raster dataset named aspect. It is raster and vector. This is called the originate row in my comparison. So let me see the most common factor we can compare with raster versus vector. The data structure of raster is what we have learned here. The most interesting part is precision. This is resolution limited, and we have the bound by resolution limit. We can't just go for ultimate zoom and found something detailed. We can do this with raster, but we have geometrically exact format with the vector dataset. That's why it is the most used case when we just use PDF in context of PNG file. So these are the most common attributes we can compare with raster dataset. And the best for if I get raster is elevation, imagery, climatery grids, and routes, parcel, and boundaries. These are the most commonly used perfection. We can just call it out with raster versus vector. And now let's just move into how we store dataset. Just we have dataset, but we have to store them, right? For that we have multiple storage format in ArcGIS Pro. We will see it later in the practical demonstration. Let me just show you what are they. The first one is short integer. It has the range of 2 to the power n, and it is 16 based. So if we just go to 16 to the power 2 to the power 16, we will get this 32,700 to 726 plus 32,768. Like total of it will be something like 60,000 plus. So we just stored small values, number values, ideal for classification data. And example said we have land covered class 1 to 10 root type code. It is the basic code short integer that we store dataset in ArcGIS. And then we have long integer. So it is 4-bit dataset. So we have 4-bit type, like we have the millions of rows we can store in this format, long integer. So large integer counts, population figures, identification numbers are stored in this format. And then we have float. So if we want to just store some decimal values, then we have to require it. Just like elevation, it can be 1 or 1.2 or anything else, NDVI, rainfall. And then we have double, which is the float 64. It just stored more than float 32. So we just require it for GPS coordinate, precise measurements of high precision, high caliber dataset. Then we need double format. And then we have the text or string type dataset. It is alphanumeric dataset, just like our names and district name or land cover dataset or whatever. And then we have date. We can store date also in ArcGIS. And we have also some additional field types and raster in exact depths. Additional attribute field types, we have blob, GUID, OID, geometry, raster field, and raster pixel band types, 4-bit. This is the most what we call the shortest form of our raster dataset. We can just give it a table, and we have the 1-bit, it is binary mask. 4-bit we have values 0 to 15. 8-bit unassigned, these are the value from 0 to 255. We have 8-bit signed values from -1 to 8 to 1 to 7. These are the most rarely used, I guess. This is the most commonly used data format we will use in Landsat based dataset. 16-bit unsigned, these are the value from 0 to 65,535. Best we have example also here, related to Landsat. So these are the most advanced and most commonly used format we will use in the modern data formats. Now let's move to our geodatabase type. We have actually kind of 3 types of geodatabase in ArcGIS. So let's just show the text here. ArcGIS uses 3 primary workspaces types to organize and store spatial data. Each has different capabilities regarding size, multi-user editing, topology, and format. Understanding their differences is crucial for data management in any GIS project. So the first one is folder geodatabase. It is actually shapefile based workspace. As we learned earlier, we require multiple file format to store a shapefile, and it is the oldest form of data we have used earlier set like ArcMap. So it has some advantages: universally compatible, no special software needed, and it is also some limitation. This is the most concerning. That's why we have moved it to file geodatabase. And then we have file format called personal geodatabase. So it is on Windows only, MDB. We have just same format that we have used like Microsoft Access or personal geodatabase we have used earlier. It has some also advantages and limitations, and the most commonly used formats are now file geodatabase, GDB. It can store up to 1 terabyte per dataset, like a huge amount of data you can use it, and we can carry like any platform like Windows, Mac, Linux, raster and vector in one geodatabase. But it also has some limitation, not an open format, single user reading, no HDE, requires ESRI diagram to read, locked during editing. So these are some constant, but most of the time we will use file geodatabase. And let's just see how shapefile component file works. So this is the detailed file formats of our shapefile we use. As I say, most of the open data formats are in shapefile already, and we can just ignore it. So the most common shape format we will use: HSP, DBF, HSX, PRJ. These are the most useful formats. Without the PRJ file, we can define the place where this file is formed. Like we will in Bangladesh, the most standard way is when a film just digitize a handmade dataset, they just delete the projection file, and that's why the entire shapefile based components are useless. So we have to manually digitize it again, and if we don't know the projection file it is based on. So these are the constraints that is just mentioned here, the limitation, and the fields field, no nulls as integer, no geodatabase feature, we can't use it. And let's move on. Personal geodatabase, Microsoft Access based geodatabase, legacy format. We just don't use it now. The personal geodatabase stores all GIS data inside a single Microsoft Access MDB file, introduced with ArcGIS 8, like very old. It was the first geodatabase format to support topology, geometric networks, and relationship classes. It is now considered a legacy format. Obviously, we can just rely on this now. These are the capabilities. It first introduced the feature class format, feature dataset, raster dataset, topology, rules, relationship classes, domain subtypes. So we can ignore it. We just don't use it now. And the most commonly used, the most advanced now current standard workspace format is file geodatabase. The file geodatabase is ESRI's preferred data storage format for ArcGIS Pro project. Stored as folder with Geodatabase extension containing binary files. It supports large dataset, raster data, topologies, networks, and attachments in all single portable workspace. So this is what we can do, and what does it contains? It contains feature class, feature dataset, raster dataset, mosaic dataset, tables, relationship classes, topology, domain and subtypes, and multiple more than that. And if we just see some key specification of this, it is extension is GDB. We have to remember it. Max dataset size 1 terabyte. Max raster size just like dataset size, and cross-platform usage and compression is built-in lossless compression available. Attachment is file linked to individual features. Editing single user enterprise geodatabase for multiple user. Driver is ESRI native. Open geodatabase driver in GDAL or QGIS. So if we just compare at a glance of all three types, so if I just give a complete overview, so this is what we can do with Shapefile, personal geodatabase, or file geodatabase. These are the competition we can just stand out for. And so what do we have learned lately? So these are the overview what we have just learned: raster dataset, vector dataset, data types, and database types. Thank you for watching. I hope you liked the video. Goodbye.